Radhe Radhe everyone. So I hope I'm audible and visible as well. Um, Let me check once, then I'll just start with today's contest. So before starting, how many questions did you guys do? YouTube. Okay, so let's get started. Okay, let's get started. I think everyone is over here. So let's get started with the first question of today's contest. It's really interesting to know that there were hardly, there were only 23 AK today. Damn, good. The last question I tried attempting, I got a TLE. During the contest, there was a wrong answer. After contest, I tried applying something and there was a TLE. Um, so it doesn't matter. Anyways, we won't be discussing the last question, okay? This was a very bad one, okay? I think I shouldn't have submitted that only. It's a, it was just a fluke on that, okay? Anyways, let's start with the first question. The first question, let me just put the mic a little bit closer to me so that things gets more audible for you guys. First question is the minimum distance between three equal elements 1. Okay, you're given an integer array nums. A tuple I, j, k of three distinct indices is good if nums of I, nums of j, and nums of k both all three of them are equal. The distance of a good tuple is the absolute value between all the three indices. Okay, that is I minus j, j minus k. Hi, good morning. I minus j, j minus k, and k minus a, k minus I. Okay, so return an integer denoting the minimum possible distance of a good tuple. If no good tuple exists, return minus 1. Okay. So if we look into this question, it says that there are three positions where the elements are equal. Okay. That is element, this element, and this element are equal, let's say. And what is the score of that tuple? The score of the tuple is absolute difference between between this, and between this and this. So if you notice one thing, this and this adds up to nothing but this. So basically the answer is twice of the absolute distance among the extreme elements. Okay, twice of that. Correct. So that is very easy to understand. That is, you know that at any position if you encounter this element, so from here you can start traversing. You get once this element, you still go on traversing. You get this element twice, you can stop. Okay, over here you can stop. There's a red signal over here. Okay, over here you have to stop. Great. So let's look into the solution. The solution is answer is equal to 2 into n plus 1. That is the maximum that is possible. Okay, the maximum that is possible is nothing but the extremes, right? So that is 2 into n, and 2 into n plus 1, just to be safe, that it denotes minus 1. Okay, that means that is not possible only. So that is why we are using 2 into n plus 1, and then we traverse throughout the whole I. We fix the value of I, the first index, and we find the frequency. Okay, so from after I, if we find that the number is present, we add it to the frequency, and if at any position we find that the frequency is 2, that means there are two elements of the same value that is occurred, that is 1 and 2. Okay, then we can stop. Correct. So we just stop over here and we just say that answer is equal to max dot min. answer comma 2 into j minus I, whichever is the minimum. Okay, so doing this, it's easy. 2 into n plus 1, if it is the maximum, if it hasn't been modified yet, then we can return minus 1 on problem 1. But when I open the second one, it is what it correct, it is minus 1 and answer. So that's it. Okay, this one was a quite simple question, not much of a thing, because the constant were very simple. Okay, the constant was 100 directly. The second question, okay, the second question, minimum distance between the three equal elements, part 2. Okay, it is very similar to this previous question. What happens over here is just the constants have increased. Okay, now it is 10 to the 5. So big O n squared is not a solution over here. Okay, big O n squared is not a solution. So let's think of like this, that we can either fix, we were what earlier we were doing. One traversal was to fix this element. Okay, the second traversal was to find the frequency of 2. But now let's say we have to sacrifice any one of them. Okay, and it is better to sacrifice this traversal part. Okay, it is better to sacrifice this traversal part. We are going to sacrifice this. We are only going to consider this, the starting points. Or let's rephrase it. We are not going to consider the starting point also. We are going to consider only the ending points. Okay. Now, if you notice one thing, this ending point and this point, what is the difference between them? How can we find out? This is the last occurrence of this. This is the last occurrence of this element. Very hard, very hard. Today's fourth one was very hard. This is the last occurrence of it, and this is the second last occurrence of it. Correct? So we can we know one thing. Okay, one thing, it was given that nums of I is in the range of 1 to n. So we can directly store, instead of earlier we were using frequency, right? I don't know which topic, man. I tried solving it, but I have a solution for the last one, which is accepted. I mean, it's not coded by me, it was coded by someone else. I was trying to understand what he has done. This is the first, I think this is the first guy who have coded it, but I haven't gone through it. Okay, it was DP, I get it, but too hard to understand, because if it would have been like the circular part was not there, then it would be a okay, still a hard question, but still on a medium part. Okay, yeah, there are only 23 accepted by the way. Now I don't know, the rating must have been refreshed, so a lot of flag must have been done, but I think yeah, 23 is a very less number considered. So now we can have a frequency array which is n plus 1 into 2. Why 2? Because the one element is going to find the last occurrence, and this element is going to find the second last occurrence. Okay, now let's say another number occurs at this position, at position I, another number occurs, which means now the second last occurrence is the last occurrence, right? And the number that has occurred at this position, now that is the last occurrence. Okay, clear? That is what we have to do. I'll go through a dry run of one of the test cases, but before that I'm just going through the code once. See, I'm having a frequency. This is not basically a frequency, it's a occurrence, or somewhat you can name it differently. Now for every specific element, I'm just making the frequency of -1. Okay, the occurrence is -1 because we haven't seen that yet. Again the same thing, 2 into n plus 1, and if answer is equal to 2 into n plus 1, then -1 is answer. Okay, this is the same thing. Now the traversal part, only one traversal is required. I'm getting the number, I'm checking if the second last occurrence is -1 or not. Because if the second last occurrence is -1, it means that it has occurred only once. So we don't have the second last occurrence. So we can ignore that. But if there is a second last occurrence, that is, it is not -1, Then the same thing, I minus frequency of x of 0. Okay, I is the current element and frequency of x is the, see, frequency of x, let's say I is this element, then this is frequency of I of 1, okay, and this is frequency of I of 0. Okay, so basically it's nothing but I minus this into 2, the same thing, we repeat the same thing and we get the answer. Let's go through one of the test cases for your better understanding. Okay. Let's go through this one. There are three elements, okay? So frequency, one will be for 1, 2 and 3. Okay, 1 is minus 1 comma minus 1. This is the last occurrence and this is the second last occurrence. 2 is also minus 1 comma minus 1. 3 is also minus 1 comma minus 1. 1 occurs, okay? So let me also write the positions of them. The positions are 0, 1, 2, 3, 4, 5 and 6. So 1 occurs at 0, so this becomes 0. Okay, and this becomes minus 1, so it remains minus 1. Now 1 again occurs, so this 0 comes over here, this becomes 0. And remember one thing, whenever we are checking, this element is minus 1 only, so we are ignoring it. Okay, this becomes 0 and this becomes 1 now. Okay, great. Now there's a 2, so this becomes minus 1, so it remains minus 1, and this becomes 2. 3 at third position, this becomes 3. 2 at fourth position, so this becomes 2 and this becomes 4. 1 at fifth position, so this becomes, wait, before making it, we have seen one thing, that over here that it is no more minus 1, it is 0 now. So 5 minus 0 is 5 into 2 is 10. Okay, that is this thing, this is a tuple, correct? 0 1 5 is a tuple. 0 1 5, 0 1 5, it is a tuple, and 0 minus 5, 5 minus 0 is 5 into 2 is 10. So we have got one of the tuples. Now there is a 6. Okay, so anyways, now it will be changed, this will become 1 and this will become 5. Okay, now again 6 comes, so this becomes 4 and this becomes 6. And also one more thing, since 6 comes, so 6 minus 2, that is 4, 4 into 2, that is 8. Okay, so for 2 we got a tuple of 8, that is this one, 2 4 and 6. Okay, 2 4 6, and for 1 we got a tuple of 10. What was our main target? It was to make it minimum, correct? Which is minimum among 10 and 8? 8 is minimum, right? So 8 is the answer. You can check, 8 is the answer. I hope this is clear for you guys. Any doubt on this, you guys can directly ask. Okay, so I'll just consider it as a no. Let's go to the last, the third question, which is the last question that I will be explaining. Anyways, The third question is maximum path score in a grid. You're given an m into n grid where each cell contains one of the values 0, 1, 2. You're also given an integer k. Okay, I'll start from beginning. The third question is maximum path score in a grid. You're given, just a minute. Okay, so let's go from the beginning. The third question is maximum path score in a grid. You're given an m into n grid where each cell contains one of the values 0, 1 or 2. You're also given an integer k. You start from top left corner 0, 0 and move on till the bottom right corner. You can only move on right or down. Each cell has specific value 0, 1, 2. 0 means that you add 0 to your score and the cost of it is 0. 1 means you add 1 to your score and cost of it is 1. 2 means you add 2 and your cost is 1 also. Okay. You return the maximum score that is achievable without exceeding a total cost of k, or minus 1 if no such valid path exists. Okay. If you reach the last step but the total cost exceeds k, the path is invalid in simple words. So minus 1 is for that condition only. Now, first let's understand what this question is telling us. It is telling us that the first element is 0. Okay, it was given in the question. Now let's say there is a 1 over here, 2 over here, 0 over here, 0 over here, 1 over here and 0 over here, or rather another 2 over here. Okay, and there was a 2 over here. The remaining of them, it doesn't matter. It is, let's say it is all zeros. Okay, it is all zeros. It is not 1. Okay, it is also 0. So if you look into this, what we are doing is basically the best optimal, and anyways k is equal to, let's say 4. Okay, or let's say 5. Let's, for the safer side, let's say 5. K is equal to 5. So what is the most best part, best path? It is this. Correct? It is this. What is the cost of it? It is 1, 2, 3, 4. The cost of it is 4 and well and good enough. It is well within our cost. We could have also gone like this also, but that wouldn't be the maximum. Okay? Because 1, 2 is greater than 1, right? So that wouldn't be the maximum. Now the point is, the whole point of this question is, there are various ways to do this. Okay. I saw the constant and DP seemed to me a good way to do it. But if you are thinking of doing it some other way, one is a greedy way. Okay, I just realized it. The greedy way is, let's say if you're at 0th position, you can either move to 2 and 1, right? That is, let's say if I'm at 0th position, or let's say I'm at any position, okay? I'm at any position, and what are the possible values that I can move on to? Right? This is 0 or 1, correct? But do you understand why this greedy is not possible for us? Because if the resultant set is very small, it is easy for us to say whether it is a greedy or not. Okay. But if the resultant set is very large, so let's say it is somewhat like this, or let's say that in greedy pattern, this is what you would come up with. That is, let's say this is one and this is two, right? So from this position, you will always go to this two, right? But what if I told you it is like this? Now this is going to be a better solution. This is not a good solution. This is a better solution. Considering that k is more than two, more than one, sorry. Correct? This is a better solution. So this greedy pattern won't work. Since that greedy pattern won't work, so that's a DP. Okay. Now, what is the dimension of the DP? See, usually DP is of dimension m into n, right? The grid, and you need another k. Okay, you need another k. What will this k do? This k will do nothing but the cost that it has occurred till now for all the k's, because that is the maximum cost that we can have at any cell. So for all the cost of k, what is the maximum score that we can have? Okay. So dpm of n of k is nothing but at current position, that is m comma n, maximum score that is possible, making k cost. Okay. You can make this m and n and k as I, j, l or somewhat like that. Okay. Doesn't matter. So from here you can get a relation. The relation is a little bit complex for you to understand. I have got two submissions. Okay. First of all, I'll explain the main submission that I have done, the first submission rather. Because the second submission is a space optimized solution. Okay. Remember one thing, whenever there is some DP questions, you can always space sort it, because the current state is dependent only on the previous state, not the other states, the previous ones, the ones which are happening way before the previous one. It is not necessary, so we can ignore that. So n into, instead of m into n into k, we can go for n into k. Two arrays we need. That is two arrays, for one is previous, one is current. Okay, we can do that. That's a possibly a good one. But first understand the DP m into n into k approach. Okay. So I'm making m into n into k plus plus, because k is possible. So you have to check for 0 to k, which means k plus 1. So, which means that the whole, this thing, it should be k plus 1. Okay. So for, I'm just filling all of the elements with minus 1. And for the first position, since it is already reachable, so I'm making it 0. Because the score of it is also 0 and it is also reachable. Okay. In any number you want, it is reachable. Now I traverse through the whole thing. I check if I minus 1 is greater than equal to 0. What does it mean? Let's say I'm at a cell. So it depends upon, it can go down or right? We know that. So if it is going down, it means it is getting derived from the cell just above it. If it is coming towards right, it means that it is derived from the cell just to the left of it. Correct? So the above it is I minus 1 comma j, and the left of it is I comma j minus 1. Correct? So I minus 1 is greater than equal to 0. That means it is in well range. So we have to consider that. So for all specific positions, if it is greater than 0, it means that it is going to contribute one cost. Okay, one cost. Which indirectly means, since it is going to have one cost, what will be the cost be? The cost will be nothing but, yeah. This is more than enough for you to understand what I'm trying to convey. Okay, only this part. This maximum part is to just check that we have to find the maximum that is possible. So I of j of L is equal to I minus 1 j of L minus 1 plus grid of I of j. Why? Because I minus 1 j is the position of the element towards the top of it. And L minus 1 because since this element is greater than 0, okay, the current element, since it is greater than 0, I have put a condition over here. Okay, if the current element is greater than 0, so it will contribute to one cost. So L minus 1 plus 1 is L. Okay, so we are just kind of having an arithmetic backtracking, back calculation rather. Okay, we are doing it, and if grid of I of j is 0 only, so it is not going to contribute in cost, neither in the score. Okay, the score or whatever it is. So it is not going to contribute in any one of them. So it is I minus 1 j of L. Okay, directly I minus 1 j of L. Similarly, you can do the same thing for j minus 1 also. I have done the same thing for j minus 1. And once you are done with all of them, the answer is basically nothing but for the last position, for all the possible values of k, okay, for all the possible values of k in the last position, whichever is going to give me the maximum answer, that is the answer. So this is basically a DP question. I hope, I think many of you have done this. I don't know how many submissions were there. Okay, so there are a lot of submissions, almost 5,000 submissions. So that's good. It's good that many of you have done this. Okay guys, so that's it. So before going off, let me rate the problems. Today I'm going to introduce a new column. Okay. What does that new column is? I'll let you know. This is E. This is medium. This is hard. And this is very hard. This is very hard. And by simply looking at it, D is very hard. Okay. A is very easy. B was, I'll still keep it on easy only. Okay. B also I'll keep it on easy. Maybe a little bit higher than A. Okay. But overall it is easy only. C was medium. There was no hard problem. There was a very hard problem. Okay. So that's it guys. Thank you guys for joining the stream. See you on the next week and weekend, next Sunday, with some other Leetcode contests. So that's it from my side. Thank you guys. Bye.